This lesson is about uncertainty in calculated quantities. This is also sometimes known as propagating uncertainty. So first, 25 plus or minus 2 centimeters, for example, is of the form x plus or minus delta x. We call the measurement x here and the absolute uncertainty delta x. The absolute uncertainty being the uncertainty that has the same units as our measured quantity. Now, if 25 centimeters is our measurement and plus or minus 2 centimeters is our absolute uncertainty, then the fractional or relative uncertainty is the absolute divided by the measurement. In other words, in this case, 2 centimeters divided by 25 centimeters, or 0.08. And if we express that as a percent, 8%, that's our percent uncertainty. We'll use those going forward. Let's talk about how we add or subtract quantities with uncertainty. If we have 25 plus or minus 2 centimeters and we subtract 10 plus or minus 1 centimeters, first we do the 25 minus 10, that gives us 15, and then in terms of our uncertainties, we add the absolute uncertainty. So it doesn't matter that we're subtracting, it would be the same if this were adding. We take 2 centimeters and we add 1 centimeter and we get plus or minus 3 centimeters. Now notice that the lowest possible value here is 23 and the highest possible value here is 11. So 23 minus 11 would give us 12. That's our lower bound. And if we took the highest possible value here, 25 plus 2, that gives us 27. And if we subtracted the smallest possible value here, 9, that would give us 18. And that's our 15 plus or minus 3. Subtract 3 gets you down to 12, and add 3 gets you up to 18. So that's why this works. So that's adding or subtracting. Quite straightforward. You just take the absolute uncertainties and add them, regardless of whether you're adding or subtracting the overall measurements. With multiplying and dividing, we need to work with the relative or percent uncertainties. So here, if we have 25 plus or minus 2 centimeters multiplied by 10 plus or minus 1 centimeters, we need to convert each of these into relative or percent uncertainties first. So that 25 would become 25 centimeters plus or minus 2 over 25, that's 8%. So I'm going to write this as 8% like this. Now I've moved the centimeters, as opposed to here where centimeters was after the uncertainty, I've moved it here so that I have 25 centimeters plus or minus 8% multiplied by 10 centimeters plus or minus 10%. Now I multiply 25 centimeters by 10 centimeters and I get 250 centimeters squared, and now I'm going to add these percent uncertainties, so plus or minus 18%. And then I work out what 18% of 250 is, which gives me 45, and then I round that to one significant figure, and that gives me 50. So I've got 250 plus or minus 50 centimeters squared. Remember, we always want our uncertainty and our quantity to have matching place values. Now, if you wanted to see another way of writing this out, you can use the formulas that you get in the formula booklet. We're working down here. This is telling you what to do when you multiply or divide things. And so we could say, let's call this area equals the uncertainty in our area. This is the absolute uncertainty, and this now altogether is the fractional uncertainty, is going to be equal to the uncertainty in each of these values. So in fact, let's erase that area there, and we'll say we already know that's 250. So the absolute uncertainty divided by 250 is going to be equal to 2 over 25 plus 1 over 10. The 2 over 25 is 2 here over 25 plus 1 over 10. Now, if you work this out and do the division, add them together, multiply by 250, then you get the 50 that we just got down here. So that's a way of showing your work. Carrying on, let's talk about raising something to a power. So this follows on as a special case of multiplying and dividing, and all we need to do is multiply the relative or the percent uncertainty by the exponent. So for example, here we've got 10 plus or minus 1 centimeter cubed. So this is equivalent to 10 centimeters plus or minus 10% cubed. And 10 centimeters cubed gives me 1,000 centimeters cubed, And now I need to multiply my percent uncertainty by the exponent. So it becomes plus or minus 30%. 10% times 3 is 30%. Now 30% of 1,000 is 300, so I get 1,000 plus or minus 300. And now I'm going to move the centimeters cubed to the end because these are now both in the same units. And just to note that the same rule would hold for fractional powers. If this was square rooted, for example, then we would be multiplying the percent uncertainty by half. Now let's talk about multiplying or dividing by pure numbers. When we do that, the absolute uncertainty gets multiplied or divided by the same pure number as the quantity, or equivalently, the relative uncertainty doesn't change. These two statements mean exactly the same. Now, let me give you an example. If we have 20 oscillations of a pendulum and we measure that to take 5.5 plus or minus 0.2 seconds, how long is one oscillation? Well, we would divide this value by 20. So 20 is a pure number. It's the number of oscillations. We're going to divide the uncertainty by that as well. So in other words, we get 5.5 seconds divided by 20 plus or minus 0.2 seconds divided by 20. And this would work also if we had something like pi or some other pure number. So our calculator gives us 0.275 seconds plus or minus 0.01 seconds, or rounding this to the same number of decimal places as this, which is what we always want to do for our uncertainties, is 0.28 plus or minus 0.01 seconds. Notice that our uncertainty, of course, has gotten 20 times smaller. So this is a clever way of ending up with a small uncertainty by bunching a lot of things together, here oscillations, and then dividing. So that's an introduction to uncertainty in calculated quantities and some of the rules we can use for them.